The fantastic OSI and TCP/IP models. I'll say the fantastic side goes to the OSI because that's really all we care about. TCP/IP gets an honorable mention. We're going to look at what is the OSI model in this nugget and really talk about why we have the OSI model. And then we'll use it, I would say, in one of the most practical ways that you would probably ever see this presented. Well, you can go layer by layer and learn and memorize the functions of them. I like showing it in more of a, here's how network communication really happens kind of way. And so we'll look at the layers, what adds what, where, and then finally we'll compare OSI to TCP/IP and find out which one's better. All right, well, let's first answer the question, what is the OSI model? And to understand that, we have to go back in time before there was an OSI model. back when dinosaurs roamed the earth. It was a very long time ago, 1970s, 1960s, that kind of time frame. And at that point, people who designed computers had no standard to adhere to. So IBM might design a computer, who was probably the only designer back then, and their network communication would only be compatible with other IBM PCs, and everybody would have to subscribe to the IBM standard until we had this standardization that was reached. So this standardized architecture helps to define how networks should and do communicate. Now, could there be someday down the road a new kind of OSI model, a new kind of way that we describe network communication? Maybe, sure, but it would be a huge change from what we're doing now. We're talking like laser beams to, I mean, it'd be something very odd to go outside of the OSI standard. Now, let me actually jump down here and it might help describe where this came from. OSI was never meant to be a standard. Let me back up. OSI was never meant to be just a model. Let me put it that way. OSI was actually a protocol that was designed to compete with TCP/IP. It was an alternative to TCP/IP, very, very similar to, remember VCRs, like that you would connect to your TV, right? There was VHS and there was Beta, right? Two different standards of how we would encode our tapes. Beta was actually better, but VHS ended up winning. Well, in the same way, OSI was, I believe, the better protocol, but TCP/IP ended up winning. And it's evidenced by the TCP/IP version 6 actually looking very similar to the old OSI protocol that we did not go with. So OSI really used this model to describe network communication, all based around their protocol, the OSI protocol. Well, as time would have it, OSI did not win. TCP/IP did, but the model itself was so good, people said, well, let's use the OSI model to describe network communication regardless of the protocol. TCP/IP, of course, being one of them, but you can actually fit just about any standard in here. And what this allows you to do is really have a couple things. A system to break down network communications. So this goes into, let me put it this way. When you become a techie person, all your relatives turn on you when they find out because they're like, oh, my computer at home is doing this, or I get these pop-ups and all this kind of stuff, right? So imagine a relative calling you and saying, hey, I've got a computer problem. Can you come over and fix it? And you're like, what kind of computer problem, right? That's going to be the first question. Let me quantify that. And they're like, I don't know, it's just a problem with my computer. I mean, you're like, I don't even, so what would you start doing? You would start asking questions to try and break down where is that, but you would say, is there lights on your computer? Do you have electricity? Does the mouse move when you move? I mean, you would start asking these clarifying questions because essentially you think of a computer in all these different layers. You're like, okay, you've got Windows up here, and then you've got, mouse and maybe drivers, and then you've got, electric cords and chips on the motherboard and all this kind of, you kind of mentally you kind of create your own little OSI type model for troubleshooting computers. Well, it's the same way in the network world. You don't just have somebody say, hey, the network's broken. You want to be able to ask clarifying questions like, well, what do you mean the network is broken? Is it slow? Is it not communicating? Does it not work? I mean, so you say, and I'm holding myself back because there's so many questions that immediately come to my mind that we haven't even talked about the technologies for, but you would start asking clarifying questions which could really pigeonhole you into what area of communication, thus what technology do you need to focus on repairing in order to get the network communication going, right? This is also a standard to create standards. What that means is that essentially we can have devices that work at each one of these that support a variety of standards. For example, at the physical and data link layer, you have Ethernet, But there was also other ones out there, and probably still are today, things like token ring, right? And that's all I'll say because that's all I can think of off the top of my head. But token ring was a competing standard to Ethernet that really changed out the data link and physical structures. It has its own kind of addressing, its own ways of sending data around the network. And you could change that out completely independent of all of this. Right? You could, so here's two different standards, Ethernet and token ring, that we could take that, swap it out. Let's just say, right, of course, everybody knows Ethernet 1, right? Ethernet is the standard. But let's just say token ring makes the comeback. You get the latest Network World magazine and front page article, token ring's back. And this big, lofty looking guy with folded arms on the front page says, I've figured out how to do 5 million gigabit per second communication with inexpensive penny price token ring network. I mean, what you would see is an immediately world change. People would start manufacturing token ring network cards. Token ring cables would be the hot item that you would go buy from the store. And I mean, it would change the world as we know it if somebody came out with something like that. But now, would it affect TCP/IP? No. TCP/IP really lives at these layers. So what we would have as TCP/IP remaining unaffected, operating systems working the same way as they always have, but we would have a new kind of cable and a new kind of way that those devices would, you would probably have to install a new network card in your computers, but self-contained would be all of the intelligence that are needed to handle this new kind of light speed ether, or sorry, I should say token ring communication. It's a standard to create standards, but it separates those standards from each other so they can be changed out without impacting it. Think of a car, right? Let's say you wanted to put leather seats in your car that currently has fabric. That's what you call them, right? Fabric seats, fabric upholstery. So you wouldn't, gut the engine and everything else. You would just change out the chairs to that new standard. And so that's the same way. That's really what the OSI model does for us: is break down our network communication and separate our communication in such a way that each area can be managed independent from the other. Well, let's now transition right into an understanding of how the OSI layers work. And I'm going to do it in terms of a practical example. First off, you can see the OSI model on the left. If you're having trouble remembering these layers, the acronym, please do not throw sausage pizza away. Or it's not an acronym, it's like a homonym or something. The first letter of each one of those, please do not throw sausage pizza away, represents each one of these layers. But I'm telling you, as you stay in the service provider realm, you will quickly learn these. You won't need a acronym or whatever you would call it to remember these kind of things. Now, notice I've divided this into two different shades of color. Purple on the top and then red on the bottom. Typically, the purple stuff happens inside of the computer, as in the application itself that you're using, whether it be a web browser or a office application or accounting package or something. It does all of this stuff inside of the package itself, or at least inside of the operating system. So as network architects and engineers and a service provider, we don't really care usually about that stuff. We're more concerned with this because this is what our network devices do to get, think of this as like, this is the application coding, that's specific to the application, and this is the network infrastructure, right? This is those layers are needed to get the data across the network and back into whatever application it's destined for. So for this example, I'd like to go practical with something you may have done before. Let's just say we are making a purchase. I think every time I go through this, I come up with a new scenario. We are making a purchase on Amazon.com. Right, going on to buy some Christmas toys for the kids. So we are on the right hand side. We have Amazon's web server. On the right hand side we have I'll put SVR. On the right hand side we have our computer, which is using a web browser. Now, this is the application layer. This is what its function is to house the, and let me say, network-aware application. Like if you're playing solitaire by yourself on a self-contained application, that's not the application layer. Where OSI model is only invoked when you have a application that wants to communicate across the network. So now let me ask you, what kind of web browser might you be using? Let me ask you directly, what do you use? Some of you might be saying, well, Internet Explorer is the one that I use, or right now, as it stands, it's always a competition, but right now I think the most popular one is Google Chrome in the industry today, followed by Internet Explorer, followed by Firefox, right, as another alternative. And I think fourth on the list is maybe Safari, Apple's alternative. But there's others as well. There's no, not Opera, Opera. I mean, there's other web browsers that are out there. Just there's text-based ones. Now, let me ask you, what on the right-hand side, what kind of web server is Amazon running? Well, chances are good if they are, like most of the world, running Apache on Linux. Or maybe they're running IIS in the Microsoft world. Or maybe they're running IBM's WebSphere. I'm giving you all these options for a reason. These are all different applications and all different web services that are out there, and it really highlights the purpose of the presentation layer. The presentation layer is where standards are developed for common communication, and we'll just call them generic standards. For the most part, exist here. Things that we might see like JPEG, it's a picture format, or HTML. Might exist here, a way of coding web pages, or let's see what else maybe. CSS. I don't know what that stands for because I'm not a web developer, but it's like a style sheet, a cascading style sheet. That's what it is. And then GIF, another picture standard. I mean, also, okay, so let's get further in our little scenario. You're on Amazon.com. You found a remote control airplane that you want to buy the kids. You've added it to your cart, and you're hitting the button on buy it now. And it says, okay, enter your credit card information. Well, I don't feel warm and fuzzy about entering my credit card information unless my web browser in the upper left-hand corner of the URL has that little lock on it, which tells me what? It's encrypted, right? Well, in order to have encryption that's supported by every single web browser and every single web server, it has to be kind of a generic encryption, and that's something that happens at the presentation layer. So as our browser communicates with the web server, it's going to negotiate and start using a generic. Now, don't hear me wrong. Don't hear me what I'm not saying. Just because I say generic encryption doesn't mean it's bad encryption. No. It is phenomenal encryption that is being used in the world today, which is very